Hello everyone, Jeff the Green Review here. Stems come in many forms, but they all have meristematic tissue in the buds that can form leaves, flowers, and roots. Buds are located at nodes. The space between the nodes is the internode. Proper pruning and plant propagation from stem cuttings need to know where nodes and internodes are located. Stems move water and nutrients from the roots to the leaves. They also transport carbohydrates back to the roots. Some stems store carbohydrates to fulfill the plant's needs during or after a dormant time. And some are the primary site of photosynthesis. Many cacti have green stems with leaves that are modified into thorns. Roots grow down and leaves grow up on a variety of stems. Below ground, modified stems can be bulbs, corms, rhizomes, and tubers. Above ground, we call modified stems crowns, spurs, stolons, and tendrils. Rhizomes are stems that grow sideways under the ground. They can be thick to store food like those of iris or peony, or thin to spread new crowns like many grasses. Other underground stems used for carbohydrate storage are called bulbs, corms, and tubers. Each eye on a potato tuber is a node. Corms like crocus and gladiolus are thick swellings of stem tissue. True bulbs like daffodil, garlic, onion, and tulip have scales that are actually modified leaves coming from a crown. A crown is stem tissue with very short internodes that produce leaves and flowers. Celery, dandelion, strawberry, and many perennials and grass plants grow from crowns. A spur also has very short internodes. Spurs are short branches on some fruit trees and on ginkgo trees. A tendril is a slender stem that is used by some plants to wrap around structure for support. Grapes and other vines have tendrils. Stolons are horizontal runners on top of the ground with long internodes between buds that can produce new plants, such as in strawberries and grasses. Palm stems have a single apical meristem, which is also referred to as the bud or heart. All new leaves and flowers develop from the apical meristem. It is surrounded by leaf bases and in palm species with a crown shaft. It is located near the crown shaft stem interface. Palms have no lateral meristems or vascular cambium layers. Death of apical meristem on a palm results in the death of that stem in clustering species and death of the entire palm in single stem species. It also means that stem wounds, which would eventually be compartmentalized and grown over in dicot trees, are permanent in palms. So what's this mean to me? Stems are the forgotten plant part. We just look at them as sticks, but they are so much more. Some grow vertical, some grow horizontal, on or under the ground. Some are many feet long, but a crown is very short. They have the buds for flowers, leaves, and roots. Some store all of the food for the plant to survive a dormant time. So what's this mean to me? You can get an idea of tree and shrub stem health by looking at terminal bud scale scars. Buds are protected by coverings of scales. As the bud grows, the scales fall off, leaving small scars visible on the stem. Terminal bud scars often form rings around the stem that are visible for several years. These scars show the amount of growth the stem has each year. Inconsistent amounts of growth may indicate an unhealthy plant. Severe weather, such as summer drought followed by fall rains, may cause terminal bud to grow and create 2 cycles of growth in a single year. What's this mean to me? Plants that spread by rhizomes and stolons can be difficult to control. The horizontal stem may send up new visible leaves for several feet from the main stem. If the stem is broken off from the main plant, it may grow as a new plant with its own roots and leaves. Rototilling a garden that has a weed growing by rhizomes or stolons may spread and establish many new baby plants. Herbicides may not be effective if they don't spread throughout the entire group of rhizomes and stolons. The weed killer may kill the main plant, but the farthest rhizomes and stolons may remain alive. Let's look at how stem tissue is formed. Stems grow very differently between monocots and dicots. Some typical dicot stems are the tree trunk, woody stems of shrubs, and the stems of perennials. Monocot stems include the hollow stems of bamboo and grass plants and the solid trunks of palm trees. The main reason they are different is the location of the vascular tissue. Think of the dicot tree trunk and you immediately think of tree rings. They are formed by the cambium cells growing between the wood and the bark. The cambium cells form 2 layers of cells. The phloem cells move carbohydrates, chemicals of all kinds, and nutrients up and down within the plant. They're growing right under the bark. And eventually, older phloem cells die and become part of the bark. The xylem cells move water from the roots to the leaves. Several years' worth of older xylem cells form the sapwood. Eventually, xylem cells that are towards the middle of the tree do not move water and become the heartwood. During the active growing period of warm weather, the xylem cells grow rapidly and they grow larger than cells produced during the colder weather and dormant period. Large cell areas alternate with small cell areas to form contrasting rings. Typically, one pair of rings is formed each year, but in cases of severe weather or drought, alternating with good weather, more than one or less than one ring could form in a year. Palm stems are typical of monocots with xylem and phloem confined to vascular bundles scattered throughout the central cylinder of the stem. They are interspersed within a matrix of thin-walled, undifferentiated parenchyma scales. Fiber cells adjacent to the phloem within the vascular bundles deposit lignin and cellulose, strengthening the oldest parts of the palm stem. Bark and heartwood and sapwood are non-living cells. The heartwood may have some water stored in it, but is not part of the active water movement flowing in the newer xylem tissue. If a tree is stressed from root damage or drought, some of that stored water and any carbohydrates in it may help the tree through the difficult time. Bark cells don't expand as the tree trunk diameter increases, so cracks develop and pieces may fall off. Some trees like sycamore or eucalyptus shed bark every summer, creating a potential fire hazard on the ground under the tree. Oaks, cork, redwood, and other trees develop thick layers of insulating bark that protects the live cambium from the heat of fires. Growth in plants is caused by both cell division and cell enlargement. Primary growth occurs at the apical meristem, and secondary growth is at the lateral meristem. Many plants reach a mature size where most apical growth slows or stops, and lateral growth continues. Sometimes this is caused by the terminal bud becoming a flower bud instead of a stem and leaf bud. Plants that do not stop growing are called indeterminate, and those that stop growing are determinate. All plants fit into one or the other category. An indeterminate silver maple can continue branch growth all summer long. Determinate pines and spruces send out a flush of growth in the spring and then stop while the needles expand in size. No more growth occurs until the following year. A rose branch with a flower on the end is also determinate. So what's this mean to me? The cambium tissue on woody plants is just underneath the bark. It is very easy to damage this tissue. If the cambium tissue is damaged all the way around a branch, stem, or trunk, the rest of the branch from that point outward will die. Fungal cankers and boring insects both kill this tissue. So what's this mean to me? Matching the cambium layers of two different plant stems is how two plants can be grafted together. It's helpful if the two stems are close to the same diameter, so the cambium tissue can be matched all the way around the stem. A graft can be successful if the cambium matches just partway around initially and then grows together better as the two stems grow larger in diameter. In other words, what's this mean to me? Whether a plant is indeterminate or determinate grower is often important for knowing when and how to prune. An indeterminate maple branch will keep growing all summer long, but a determinate white pine branch will grow a little while in the spring and then stop until the next spring. See my pruning videos for more details. There are indeterminate and determinate tomatoes. Indeterminate tomatoes require larger trellises and continue to produce fruit all season long, while determinate tomatoes stop growing in size and produce all their fruit at once. If you want to can your tomatoes, buy a determinate variety that produces a lot of fruit all at once and then can be processed in a large batch, and then you're done. And then you can remove those tomatoes from the garden and plant something else. Indeterminate tomatoes are better for eating a few at a time all season long. Another what's this mean to me? Garden center people are often asked for fast-growing trees because people are in a hurry and they may not stay in their house too long, so they want a large tree as quick as possible. How does a fast-growing tree get to be larger, faster? It grows larger cells. Larger cells have more empty space, making fast-growing trees weaker when storms, winds, or other problems come along. Many supposedly slow-growing forest trees grow quickly during their first few decades and become slow growers later in life. This allows them to grow quickly towards the sunshine as a small tree in the forest, and when they've reserved their cells some sunlight, growth slows and they can last a long time. If you need a shade tree, consider buying a forest tree, such as an oak, that will last a long time, rather than a fast-growing tree that will become a hazard. The resale value of the forest tree in your yard is better than the fast-growing tree that potential home buyers may not want. Wood that is produced with small cells has more cellulose-laden cell walls in the wood. This wood is heavier and stronger than wood produced by larger cells, containing more empty space. Small cell wood has much more cellulose to burn, so it burns hotter and longer when used as firewood. And this is Jeff with a Greener View. Thanks for watching.